welcome back. We've got lecture 4 right now. And here, this will be actually a shorter lecture. Basically, because there's no solution. So, but I do want you to see what's going on when the computer cannot find a solution. Okay, so for this particular problem, I have chosen a simple one. Okay, there we go. So we're going to minimize this function. We're going to minimize 6x1 plus 24x2 subject to x1 plus 2x2 greater than or equal to 3, x1 plus 4x2 greater than or equal to 4, and then of course finally x1 and x2 greater than or equal to 0, right? My non-negativity constraints. Okay, so we're going to set this up the way we always do, right? Here is our x1 axis. Here's our x2 axis. So let's take our first constraint, right? So we've got 2x2 greater than or equal to 3 minus x1, or, right, x2 greater than or equal to 1.5 minus 0.5 x1. Okay, so here's my 1.5, and come on, just draw. Yeah. Okay, do it again. Yeah, whatever. 3, right? And then, of course, I need a color. Go yellow, right? Greater than. So I'm out in this region. Okay. And here was my yellow constraint. Okay, so let me go back. Okay. Oh, look, that stays up. See, and I've learned something new. Oh, jeez, I'm going to become an expert at this stuff. All right. So, look at that, clear all this. Now I have to do the same thing for this constraint, right? So 4x2 greater than or equal to 4, minus x1, or x2 greater than or equal to 1 minus 0.25 x1. Right, so again, here, I'm going to go to 1, to 4, click on that, and now I've got my green, right, because these are all greater than or equal to's. Right, and so you can clearly see, right, that right now, well, I hope you can. I shouldn't say you can clearly see it. I certainly hope you can see that right now I should have had some yellow in this area, right? But it's this line, kink, down to here. That's where both constraints are going to be satisfied, right? So let me draw that in. Kink, right, go down to here. And then what that does is that allows me to delete that stuff. Well, I'll get rid of the green one. All right, what the heck. So we've got this area out here. See, the nice thing is now that I can click on that so much easier, I just put the green right back in there. Okay, at any rate, I digress. So we've got this kink point here, okay? Well, now let's take a look at our objective function. And I got to solve for this. So, oops, my bad. Go here. So, 6x1 plus 24x2, right, is equal to some constant, right? So therefore, 24x2, right, is equal to c minus 6x1. I don't know why. Yeah, there it goes, 6x1. Divide both sides by 24, right, and I am going to get x2 is equal to c divided by 24 Now, 6 divided by 24 is 1/4, or 0.25 x1. Okay? It turns out that your objective function has the exact same slope as one of your constraints, right? This one in particular, right? 4x2 greater than or equal to 4 minus x1, or x2 greater than or equal to 1 minus 1. Well, I don't know why I did 1/4. That was stupid. 0.25 x1. Right? Now here is what I'm trying to drive at. Right? So just so that we're clear, let me get this out. That was this, just so we're clear, guys. That was this line, right? That went from 4 to 1. Okay? So what I am trying to get you to see is, look, let me just get rid of all this extra stuff. Okay? Come on. Thank you. Okay. Well, look, here's what I'm getting you to see. Okay, I want my marker back. Look, check this out. Let C equal 24. Then x2 equals 1 minus 0.25 x1. And all of a sudden, right, your objective function is equal to your constraint. Now, don't worry about the greater than, because what that means is that your objective function, right, your isocost line, will lie directly on that constraint. Okay? So what that means is at any point from this kink point to this, to 4, 0, we'll return the same amount of cost, minimized cost, right? So in other words, from this kink point, right, to the point 40, right, your cost is going to be the same. So there is no unique solution, right? Any point on that line would satisfy that objective function. So here is the case in which, you would not find a unique solution. And I'm actually going to show you this in the computer, because the computer is going to give you an error message. And I just want you to be cognizant of what that error message means and, right, what happens. Okay, why is that happening, right? Because basically there is no unique solution. All right? So I hope this made sense to everyone, right? The idea here, when you don't find a unique solution, the idea here is that your objective function lies on top of one of your constraints. As a result, there are multiple, right, numerous points that satisfy your objective function. Therefore, the computer cannot give you a unique solution, right? So in this case, like the 0.40 would satisfy that. And then, if we could find what this kink point is, right? Just set these two equations equal to each other, find the kink point. Well, that 0.2 would solve the min function. All right? So, at any rate, I don't want to belabor that anymore. But that is what is going on when you don't find a unique solution. Okay. Well, you are more than halfway done with the week 1 videos. I've got 3 left. Now what I'm going to do is show you how to solve all of these in Microsoft Excel. I want to reiterate that I do not expect you to solve these graphically. I strongly encourage you to read the book. I think, the book's has much better graphs than I do, right? So I would read the book for that reason alone. But the book talks about graphically solving all 3 of these cases: a max, a min, and then a no solution. What we're going to do next, and what I want you to do for the rest of this term, and quite frankly the rest of your career, is to solve these using Microsoft Solver, all right? And that's your homework will be using Microsoft Solver, all right? So I have talked for far too long. That is it for this video. You've got 3 left, and I will see you in the next video. All right, take care.